Let's discuss about light. If you have any questions, you can ask me. I have. Let's discuss. What is light? It is a source of energy, right? How we'll receive it? We'll receive it from sun, or we also have artificial methods of receiving light from. We have bulbs, fluorescent bulbs, different kinds of bulbs, right? From those also we can receive light. So here we need to know different types of lenses and mirrors here to know about the light. And also we'll discuss about some of the instruments which we'll discuss in the light topic. And go on, you will be understanding clearly about the light. Here, first of all, without light we can't observe any image, right? In a dark room, can you observe any image? No, right? With the presence of light only, you can visible. You can clearly observe, or the image will be visible for you clearly. So there should be a light, a source of light should be there. So here, let's take a mirror. Let's take a mirror. We need to observe what is incident ray, reflected ray, refracted ray. Here, I have taken a light source. Let's suppose I have taken a torch and incident on a glass plate. So here, this will be the incident ray. Let's draw a normal. This is normal ray. Can you observe this? This is normal ray. Here, this is a reflected ray. What is reflection here? The angle with which the light is incident on the mirror. That is called incident ray. The angle with which the light is reflected back. That is called reflected ray. Here, this normal line will be making 90 degrees with the glass plate. Here, incident ray. What is the incident ray makes here? And the reflected ray. To know the angles between them, we have two laws. Two laws of light. There are two laws. What are those laws? Here, first law is angle of incidence equal to angle of reflection. Here, angle of incidence should be equal to angle of reflection. That is first law. Here, the normal made perpendicular angle with the glass surface. So here, this is 90 degrees means angle of incidence will be what? This total angle is made 90 degrees. So here, first law, that is angle of incidence equal to angle of reflection. So 90 means 45 and 45. This will be 45 degrees angle. This will be 45 degrees angle. So total will be 90 degrees. What is the second law? Here, incident light ray and reflected light ray and normal. The point of incidence must lie in the same plane. Here, to know that, we need to do a practical. As you know, you have already done previously, I think. Let's discuss that. Here, let's take a paper. Near that, keep a torchlight. Keep a torch. This is the source of light. Here, from this, rays of light are coming. Here, let's suppose I kept a glass plate. Here, the light rays are incident on this glass plate and reflected back. This will be normal. This is incident ray. This is reflected ray. Here incident ray, reflected ray and point of incidence all lie in the same plane here. Let's suppose I have curled this. I have folded this paper till here. I have folded. If you observe, the reflected ray will not go beyond this line, because the folded paper plate will act like a different, it will be like different. Light it is not in the same plane. That will act like a different plane. What is the rule for us? Angle of incidence, reflection and point of incidence. That is normal. Should lie in the same plane, right? So, here, this is not possible. That only explained in that experiment here below. So, all should lie in same plane. And we also discussed multiple reflections, right? Where did we discuss multiple reflections? Here, pinhole camera or in a kaleidoscope, you also observe, what did you observe? And kaleidoscope, we have we have different instruments which follows the rule of multiple reflections. Here, let's take a kaleidoscope. This is made up of cardboard. Let's how it will be? It will be like a triangular shaped glass plates are placed like this. Here, what happens when the light travels? Here, this will make, here there will be a hole. Let's suppose light is traveled to this. Here, the glass pieces are kept inside this prism. What happens when light passes? It will be incident on these pieces. Here, if you observe from here, you will observe that multiple different colors will be formed due to reflections. Here, when it is fall on this piece of glass, what happens? This will be reflected. And multiple reflections will be taking place in this kaleidoscope. Here, due to these multiple reflections, we observe different colors. Here, if you observe rainbow is also a multiple reflections. Here, if you observe the cloud, here the water particles stick to, after rain, what happens? Some water particles stick to the cloud, right? Here, let's suppose take a water particle. When light falls on this water particle, when sunlight falls on this will be reflected back. Here, multiple reflections will be taking place inside this water. Here, this water acts like an optical medium, like a glass surface. When multiple reflections takes place, here we observe different colors like Vibzior, violet, indigo, blue, green, yellow, orange. Different colors will be observed due to the dispersion phenomena. This is nothing but multiple reflections will be taking inside the glass like a water bubble. Here we also have a periscope. This will be like this. Here, if you place a glass plate, 2 glass plates are kept during the starting of this cardboard and ending of this. Here, what happens? When light falls on this will be reflected and transmitted. Here, light will be transferred like this. Here also, reflections are taking place. Due to reflections only, here, this will be used in many applications. Like if you observe in the ships or submarines, the people which are under that water, they will observe from this. And they will get to know how different images or what everything is going on the earth, like on the surface of the earth. They will be in water, no? They wanted to know what is the conditions going on, what are the weather conditions or atmospheric conditions going on the surface. So they will be known by using this periscope. So here also we can observe reflection of light, right? Here, we have regular reflection, and in reflections we have regular and diffuse reflections. What is regular reflection? Regular reflection. Let's take a smooth surface. Let's take a smooth glass surface. When light falls on it, what happens? Let's take a smooth glass surface. When light falls on it, that will be reflected. Here, incident ray, reflected ray. Incident ray, reflected ray. Here, incident ray, reflected ray. Here, the reflected ray. Let's take normal. Here, incident ray, reflected ray. Here, if you observe, the reflected ray is parallel to the incident ray. Here, all the reflected rays are parallel to the incident ray in a regular reflection. Here, you will observe these type of phenomena on the smooth surfaces like marbles or any other smooth surfaces. When light falls on this glass plate or any other surfaces which are very smooth, which are having very less irregularities. Every body will be having irregularities. There is no ideal body which is very smooth. But we can take a body which is having 98% of smooth surface and 2% of with irregularities, that we consider as like a marble floor. These all comes under regular reflection. Here, these regular reflection takes place on the surfaces. Here we have irregular reflection. Irregular reflection. What is irregular reflection? What is irregular reflection? When light falls on a rugged surface, like a rough surface, what happens here? When light falls on a rough surface, it will be, here it is incident ray, let's suppose. Here, these are the incident rays. The reflected rays may be not same, like it will be different. These are the reflected rays. These are not parallel to the incident rays, and they are traveling in different directions. If you observe, they will travel in different directions because the path, here the path is not plane, it is irregular surface. Due to that, what happens? The reflected rays are all not going in the same directions. They are not, they are not traveling in a parallel direction. So here, the reflected rays travels in a different directions. Here, if you want to find out, like, if you want to, in kaleidoscope, we have seen, no? If you want to find out the multiple reflections, if you want to find out the images formed, we can find out with this formula. Here, 360 by x minus 1 equal to 0. Here, x is the distance between the image and the glass plate. Here, till now we have discussed irregular and regular reflections. Here, we also have different types of mirrors. What are the mirrors we have? Plane mirror. The mirrors which we see our face in the mirror. Like daily mirrors we will see, no? Those are normal mirrors. Those are plane mirrors. Plane mirrors. We have plane mirrors, and spherical mirrors. What are spherical mirrors? What are spherical mirrors? They are curved in nature. We have two types of spherical mirrors. One is convex. Other is concave. Here, convex lens means what it do? Here, it is, here if you observe, the inside it is painted. Like, painted with a silver coating. Why it is painted? To transfer the light. If you observe our plane mirrors, how can we see our image? The back side is coated. Now, if you observe that the plastic cover will be there. If you remove that, you will see a silver coated metal will be there inside, back of that. With that only, you can see your image. Otherwise, the light will be transmitted back of that mirror. Here, for that only we have, for the reflection phenomena to take place, we have coated this with a silver coating. The back of this concave mirror, it is coated with silver coating. Here, we observe our image. How we will observe? Let's suppose, take a plane mirror. Here, this is the mirror, regular mirror which we see in our day-to-day life. Like in our home. Here, let's suppose a light is incident on it. This is the normal. It will be reflected. Incident ray, normal. Here, the reflected ray will be travel towards our retina. It will be incident on our retina. With that only we can observe the image of our face in the mirror. So it is again a reflection process. Here, the reflection taking place. With the reflection only we can observe the image. Here, if you comes to the convex and concave, here convex lenses. Where convex lenses are used, here, the convex lens. Convex lens is used in where we can use in the rear view of the mirror. Like side mirrors will be there, no, for vehicles, and also we'll observe in ambulance vehicles. We also observe different rear view mirrors and hill view mirrors. If you turn in the hill views, there will be some a large shaped mirrors will be there. These also are convex mirrors. What this will do here, the objects which are far away also can be seen with this convex lens. Here, in a hill view, the objects which are away also can be visible. Here, the object size will be diminished. If you take convex lens, the object size will be diminished and inverted. Diminished and erect. Erect and diminished. Images will be formed. Erect means what? Let's suppose Here, when the light rays are falling on this mirror, these rays will be reflected. These rays will be reflected and fall and will be focused on a particular point. Here, distance from pole, center of curvature to the here focal point is called. Here focal point is called. This distance is called focal length. This total distance is called focal length. Here, these type of images are erect means what? If you see in a image, like in a mirror, we'll observe an image like as it is, right? It will not be reversed. It will be in a same size like us. Like here, erect means it will be, let's take a candle here. We can observe, in this mirror, we can observe the candle like this, as it is. But diminish. The size of the image will be very less. Here, erect and diminished images will be formed by using convex lens. And here, if you observe concave, if you observe concave lens, what? Here, if you observe concave lens, what happens to it? Here, let's suppose these all rays will be focused at a particular point. Let's draw a parallel lines to this. Here, what happens? The image will be formed back of the mirror, beyond the mirror here. But here, the image will be not erect. Here it is inverted image. Inverted. Here it is enlarged. Inverted means what? Here, if you observe, if you take a candle here, the candle here you can observe is inverted. Like it will be reversed. But the size of it will be very big. Here because these, if you observe, if you take a spoon, front side, you will observe as a convex lens, concave lens. Front side, if you observe, our image will be very large and it will be reversed in shape. Reverse. Here, if you observe convex, it is like a erect, but it is erect and same size. Here, the back of the spoon will act like that. Back of the spoon will act like a convex lens and front side of the spoon will act like a concave lens. Here, the image will be enlarged. We can observe these type of images where we can observe. We can observe in like dentists will be using these images like these concave mirrors to observe teeth. Their enlarged images will be formed. Here, if you take a concave lens and keep it in the mirror, keep it in the sun, and here, below that, if you keep a paper, what happens? The rays are not converged there. There, if you see, the rays are diverged. Here, if you observe, the rays are converged. Due to that, what happens? The paper gets burnt. The burning of paper takes place due to the convergence of the rays. Due to this hotness, the rays will be burned. Yeah, these also will be used in some of the vehicles. Lateral inversion. What is lateral inversion? It is very useful. If you observe our image in the mirror, what happens? It will be like, it will be reversed, no? Like, not everything like that. If you observe in the mirror, our right, here let's take a bag is here. It will be, Here right side will appear left and left side will appear right. If you take the mirror. Here, what it is happening, why it is happening? Left is visible like in the right side, right is visible in the left side. This is due to the lateral inversion. Lateral inversion which we can see in the mirrors. Why? If you see ambulance name, it should be like this, no? But it will be like this. It will be reversed. These letters also will be reversed. Why it is reversed? Like it will be reversed. It is reversed because to observe. Here, if it is in reverse position, what happens? The viewer which is seeing in the front wheel of the vehicle, it will be in reverse position. It is in reverse position, no? Due to the lateral inversion, it will appear correct in the rear view of the mirror. For that only, here, it is written like that. Spectrum. What is the spectrum? Here, if you take a glass, like a prism, a glass prism, or any optical medium, what happens? What happens here? Here, when applying sunlight, like light propagates in which direction? In a straight line, right? Rectilinear propagation of light will be there. Here, light travels in a straight line path. Here, to observe the straight line propagation, if you take a pipe and pass the light, we can observe the clear image of outside. What it is? What here? Let's take let's suppose we are observing a tree. We can observe it clearly by using this straight line pipe. We can discuss this later. Here, if you see a bent pipe, here you cannot observe the image because the light travels in a straight line path. Here it is bent, so light cannot travel. Light only travels in a straight line path. Rectilinear propagation. Rectilinear propagation of light. Here, we are discussing about prism, no? You take a prism. When light, allow the light to pass through the prism. What happens? It will be traveling. Here, it will be bent. There. When sunlight falls on it,